Okay, folks, I am going to walk you through how to take data for this super cool incline video lab. So the first thing you're going to do is use this link to open the video analysis app. It should set you straight in there, and then you need to import a video to take data. So we are going to choose the file. This is going straight to my desktop where I saved all the videos I made for y'all. Let's say that you're doing the 6-degree incline video lab. Make sure you open up the one that is assigned to you, but you will be able to check your work because you can see I put a little index card, propped a little index card there to let you know that this is a 6-degree incline. Okay, a couple of pieces of advice. You want to be able to focus on this. You want to make this part of your screen as large as possible so you can slide this over. Then we can focus on the graph. Now we can focus on the video. Okay, so you have to do a couple of things to make sure that it's calibrated. So you want to go to System, and you want to set the scale, right? The computer doesn't know how far apart, how far away my camera was when I took video. The default distance was 1 meter. So I put a piece of white electrical tape at here, which is also going to be our starting line. So align this to the very left of that piece of tape. And then I put a meter stick along the track, and you want to line this all the way up to the very left piece of that tape. And that is a meter. All right, you just have to trust me that that is a meter. I set that up for you. That's the default. You do not have to change this number. Okay, nothing's going to happen. You're not going to know that it registered. You're just going to have to trust me that it did. So this means that 504 pixels, that's how much space, is taken up, is defined as 1 meter. So that's calibrated. The next thing you have to do is decide where X and Y equal 0 are. Okay, so we're going to make it easy on ourselves. Where they label Y means that's defining positive. So this is saying up is positive, and the default is to the right is positive. I think you'll be happier if we rotate this so that up the incline is positive. Okay, and I'm asking everybody to do it because you're going to be comparing some things. So you're going to flip this all the way around so that up the incline is positive. Try to make this as parallel to the track as possible. And then you're going to take this bullseye or compass, and you're going to put it at the end of that white tape. So you were defining this point as the origin. That's where we're going to start taking data for the cart. But we're defining up the ramp as positive because I think it'll make it easier to understand what's going on. Okay, and then it's a little bit annoying to get rid of this. Just click on distance, and then all those other things go away. All right, so we've set the scale. We have defined the origin. Now, let me show you what these controls are. Play, clearly the cart's going to go up and come back down. Okay. Each of these arrows moves it forward 1 frame. So you're going to click forward 1 frame until I tried to edit out most of this parts of the video where nothing was happening. But you're going to keep clicking until I put a piece of a little black tape on the cart. When that little piece of black tape, right now it's still behind the starting line. The white tape is the starting line. So at some point, it'll be ahead of the starting line. It's not going to line up perfectly because, the frame rate was only so fast. But as soon as the black tape is ahead of that white tape, you are going to start taking data. So that means you're going to go up here and you're going to add. And you get another little bullseye, and you're going to click on that black electrical tape, and it's going to move forward a frame, and then the cart move forward. You're going to click on it again and again and again. The trails are going to be kind of annoying. In theory, each trail should be closer, because this is slowing down. The distance should be decreasing. I didn't find that super convincing until we get to the vertex. And it's going to backtrack. So we're going to turn the trails off. They're not gone. You can turn them back on. We're just going to turn them off so that you can focus on that black dot. And you can see what is happening is that we're building our parabola. And you're just going to keep clicking. And then at some point, I pause the video for a little bit. At some point, you're going to feel like, oh my God, I am clicking and it's not moving, because guess what? You're going to be, the closer you are to the vertex, the slower you're going to be going, the more tedious this click job is going to be. But then at some point, you can see it has started to move down. So you can see that you have passed the vertex when momentarily it was not going anywhere. Okay, and you are going to keep clicking until you make it all the way back down. Okay, so then you're going to keep clicking until the black dot returns to the starting point. Yay, you are done taking data. So you could turn the trails on again, but it's backtracked, so I don't think that's super helpful. But let's slide over. Look at that beautiful parabola. Okay, it is concave down because the Earth, the environment was the Earth pulling it down the incline. Okay, awesome. So pay attention here, because all of this stuff is, like, you've used videos before. This is new and tricky. Okay, so you're going to click on this. We don't really care about the y-axis. You can see that nothing was happening up and down. The cart was only moving along the track, not perpendicular to the track. So I'm going to turn that off because it's not really interesting. And let's see if we can, I don't think it's going to tell you you can kind of estimate, oh, here, look, it is telling you, I think, where the peak is. So the maximum height, it looks like, is, oh, hang on, I'm going to change something. Okay, so I changed the scale to be wrong so that whoever has this data set makes their own data. But I think it's telling you that the maximum distance is 0.684 at 1.23 seconds. So I may or may not have you do something with that. So know that before you get out of the parabola, you can find the maximum height. Okay, and the time that happens. So that's when it reaches the peak. Okay, but we are going to practice looking at, because we made position versus time graphs in the first lab. So what we're going to look at is the x velocity. You may change that, I believe, to whatever color you want or whatever symbols you want. And that's what we care about. And we don't really care about the data. I was going to have you copy this to Desmos, but ooh, that's a lot. So we're going to just use this program. So in theory, this is a beautiful line because the slope is the acceleration and the environment was pulling down at a constant rate, right? But things are blurry. There's also what's called parallax, which we don't have to talk about right now. Okay, so this is the velocity. Again, this is the time that it was at the peak. You're not going to get zero definitely head on, right? The chance that you one of the frames, like the bird in the cage, one of the frames was flashing when the cart was exactly at the peak. Not very likely. Okay, so but you should have a beautiful line with a negative slope because the slope is acceleration and the Earth is pulling down what we're defining as negative or down the incline. Okay, so that's check number one. And then you're going to go over here and you're going to apply a curve fit. And the curve fit could not be easier. It's going to be linear. And then you are going to write down y equals mx plus b is the equation of a line. And the slope of the line, look at the units there, is negative 0.8737 meters per second because the rise is meters per second and the run is seconds. Okay, so that really is just another way of saying meters per second squared. That's your acceleration. Okay, you are going to write that down. B is your y-intercept, which is a 1.07 meters per second. That's how fast your cart was going at t equals 0. And then R is some kind of statistics, root mean square error. Like the closer R is to 1, I believe, the better it is, and the smaller the root mean square error, the better your data is, right? And so my data is, you can see, it's not a beautiful line. So that's just telling you how clean the data is, but the two numbers you need to write down are the slope, which is M, and the y-intercept, which is B. All right, and then I would like you to, and these are not the right numbers because I changed the scale. I deliberately mucked up the scale. So I'm modeling what you're going to do. And then you need to take a screenshot of this and email it to jgroppy@murray.org. And I think that is all you need from the video. All right, so I hope it goes well.